What if our economy didn't drill, but grew instead? An economy that runs not on finite fossil fuels, but on the living, renewable systems that are all around us. And look, this isn't some far-off sci-fi dream. It's what we call the bioeconomy, and it promises a radically more sustainable future.
Okay, but there's a huge catch, right? I mean, if this new economy is made up of everything from tiny microbes in the soil to, entire forests, how on earth do you even begin to measure it? How can we track its health, its growth, and its actual impact on the world? So, at its heart, the bioeconomy is this incredible vision. It's all about using biology as our main technology. We're talking about things like biofuels made from algae, plastics from corn that actually biodegrade, and even medicines developed using genetic engineering. It's a total rethink of our industrial world.
And that amazing vision, well, it brings us right back to a really fundamental problem. See, before we can really build this biological future, we have to solve this giant measurement problem.
You've probably heard this before, and it's a classic for a reason. If we want to guide the bioeconomy, if we want to invest in it smartly and make sure it's actually sustainable, we've got to be able to see it clearly. And for the longest time, we just couldn't. So what makes it so tough to track? Well, think of it like you're trying to build a puzzle, but all the pieces came from completely different boxes. The data you need, it's scattered all over the place in agriculture, genetics, economics, you name it. And the models that scientists use in each field, they basically speak different languages. They just don't talk to each other. This fragmentation meant we were only ever seeing these tiny, isolated pieces, never the full picture.
Okay, so how do you connect all of those scattered puzzle pieces? Well, the answer, as this research points out, lies in the digital world. That's the key, the framework we need to finally connect all the dots.
So to get their arms around this, researchers came up with a really clear three-step plan. First, on the left, they defined what the core ideas of the bioeconomy even are. Simple enough. Second, they mapped out the entire landscape of digital technologies available. And then, and this is the crucial part, they analyzed where those two worlds overlap. They pinpointed exactly how digital tools could finally bridge that gap and help us measure and understand our biological world.
And what they found is absolutely fascinating. It turns out the number one biggest enabler for the bioeconomy, it's data science and analytics. And we're not just talking about collecting data. We're talking about using powerful tools like AI and machine learning to make sense of it all. Right behind that, you've got powerful computing and super advanced sensors. These toolkits are basically forming the central nervous system for this whole new way of thinking about our economy.
Okay, so that all sounds pretty high-tech. But what does it actually look like in the real world? Let's break it down and look at the three main pillars of the bioeconomy. All right, first up, we have the biomass bioeconomy. This is the part that's probably easiest for us to picture. It's all about using physical, tangible resources, things like crops, trees, and other organic stuff, as the raw materials for everything from energy to the products we buy. Okay, so here's a classic problem. Imagine you're a farmer. How do you know what's really going on in the soil across thousands of acres without digging the whole thing up? Well, the digital solution here is just incredible. Get this. Researchers have developed these acoustic sensors that send sound waves into the ground and then analyze the echo. They can literally listen to the soil to figure out its texture and composition. This gives farmers a precise, real-time map of their most valuable asset. How cool is that? Okay, now let's zoom way, way in. From farms and forests down to the microscopic level. This is the biotechnology bioeconomy. And this is where we're not just using nature, we're actively engineering it. We're designing and building with life itself. And this is where things get seriously mind-bending. Instead of putting patients at risk in early clinical trials for heart disease, scientists can now build what's called a digital twin of a human heart. It's this hyper-realistic computer model built on 75 different biological parameters that lets them test new drugs and treatments with unbelievable precision, all before a new medicine ever gets near a human being. So what's the engine driving all this innovation? It's massive open access data. The Protein Data Bank is a perfect example of this. It's basically a shared global library with over 210,000 3D models of biological structures. This kind of shared knowledge is pushing discovery forward at a speed we have just never seen before. All right, so from the micro, let's zoom all the way back out to the macro. This is the biosphere bioeconomy. This is all about understanding the big picture, the health of our planet's ecosystems, the flow of energy, and those huge natural cycles that, sustain all of us. So, on this huge planetary scale, digital tools can kind of act like an immune system for our ecosystems. For instance, researchers have developed these amazing cell free biosensors. They're like tiny biological machines that can detect really harmful herbicides in our water at microscopic levels. This gives us the power to spot threats super early and protect our most vital resources. So, when you step back and put all these pieces together, what does it all mean? It means we are finally building the tools we need to measure a better, more sustainable future. When you boil it all down, digitalization is the bridge. It's what connects the super complex physical world of biology with the clear analytical power of data. It's what turns the bioeconomy from this hopeful idea into something we can actually measure and manage. It makes it real.
So for the very first time, the blueprint is actually starting to become clear. We're developing the senses we need to understand the complex language of nature. And that leaves us with the most important question of all. Now that we can finally measure it, what kind of world are we going to choose to build?